Okay, cool. Broadcasting. Hey folks, welcome to the webinar tonight. We'll just give it a minute as people trickle in, and we'll get started in just a moment. Hello folks, this is Melanie from Epicured. I just want to let you know we're going to get started in just a minute, just letting some folks trickle in here. Hey folks, this is Melanie from Epicured. Thank you all for joining us today to hear Tamara Duker-Freundman discuss diagnostic testing in digestive disease. For those of you who are new to Epicured's clinical webinar series, I did want to take a moment to introduce myself as well as what we do here at Epicured. So my name is Melanie Klesse. I'm a registered dietitian working at Epicured. I also see my own patients at Nutrition Energy, a private practice here in New York City. Just a little bit of background on Epicured. Epicured is a healthcare company that provides food as medicine in a really practical way for your patients. We deliver low FODMAP and gluten-free, fully prepared meals to people in the Northeast managing digestive disorders. I have the privilege of working with and building our Partners in Health clinical community of registered dietitians, gastroenterologists, primary care physicians, and other practitioners who see our meals as a resource for their patients, and to support the clinicians themselves in improving their education and helping improve their patients' adherence to the low FODMAP diet. So before we get started, I did just want to go over a little bit of housekeeping. So you all have been placed on mute to ensure that our wonderful speaker is audible today. But please, as we go along, please send in any questions as you think of them through the Q&A function at the bottom of your screen, and then I'll address them to Tamara at the end of the webinar. So now on to the content. I am so thrilled to have Tamara here with us today. Tamara Duker-Freundman is a nationally known expert in digestive health and medical nutrition therapy for gastrointestinal diseases. She is a registered dietitian and New York State certified dietitian nutritionist who holds a Master's of Science degree in clinical nutrition from New York University. Tamara is a member of East River Gastroenterology and Nutrition, a private Manhattan-based practice known for its expertise in functional bowel disorders and specialized diagnostics. In professional medical and academic circles, she is a frequent lecturer on topics pertaining to digestive health, both in person and online, often through the Academy of Nutrition and Dietetics and its various state and local affiliates. Don't miss her highly anticipated talk at Bensi this year entitled Beyond Brat, Tailored Diet Interventions for Chronic Diarrhea. In addition to her clinical work, Tamara is a high-profile nutrition writer whose advice on healthy living and dietary management of digestive disease is read by hundreds of thousands of people each month via leading online media publications like US News and World Report's Eat and Run blog and its syndicate, Yahoo Health. She is the author of The Bloated Belly Whisperer, which was released last December, and she co-authored the chapter on gastrointestinal problems in the older adult for the second and third editions of the textbook Nutrition for the Older Adult. Tamara graduated summa cum laude from Duke University and prior to her career in dietetics, completed a Master's of Science degree from Georgetown University's School of Foreign Service. Thanks so much, Tamara, for taking the time with us today. I'm really personally looking forward to your discussion of this topic, and I'll pass the controls over to you from here.
Excellent. Thank you, everyone, for joining us today. I am Tamara, and we have so much to cover, so I'm going to dive right in. And the way that this is going to work is, I have a lot sort of upfront slides that's kind of background and context before we jump into the breath testing and stool microbiome part of the talk. And while I know that we're all eager to get to kind of the meat of what was advertised, I think it's really important for people who don't work necessarily in a GI setting on a day-to-day basis to be at least somewhat familiar with a really broad array of the type of tests that a gastroenterologist might order for their digestive patients. Because very often with some of the newer tests, you're going to hear practitioners ordering those tests claiming that they can measure this or measure that, or I'm ordering this test in order to see if you have this disease or to diagnose that disease. And I think it's important for all of us clinicians to really understand what tests are available to measure what things, so that you can understand whether a test that's being promised as diagnostic of something is actually diagnostic of that thing, and what the other options are. The more you know, right? So we're going to dive right in, and first we're just going to ground ourselves in some basic facts and terminology that we're going to be using throughout this talk. And so the first is the gut microbiota, which, unless you've been living under a rock, you've heard of. And this really refers to the ecosystem of microorganisms that are living in your digestive tract, everywhere from your mouth to your colon, although often we tend to think of it as the critters in your colon. There's 100 trillion microbes in there. The estimates vary, around 1,000 different species. Again, we tend to think of them mostly in terms of bacteria, but there's other critters in there too. There's some yeasts, there's some viruses, and there's some microorganisms that are bacteria-ish called archaea, which become important as we talk about breath testing for bacterial overgrowth. And everyone's microbiome or microbiota is a little bit different, kind of like a fingerprint. No two people are the same. When we think about the gut microbiota, we have bacteria pretty much all along the way. The highest concentrations are going to be found in the areas that have the most contact with the outside world, I guess. So like the mouth and the colon. And so sort of as we progress inside the body from stomach to colon, we see progressively higher concentrations, really exponential growth of microbial life. So the stomach, because of its very, very acidic pH, is, for all intents and purposes, sterile, right? Like basically very little can live there except maybe some H. pylori, which shouldn't. And then as you continue along and the pH changes, the concentrations, the abundance of the microbial community increases, so that by the time you get to the jejunum, which is sort of, the middle part of the small intestine, every ml of secretion has about 1 × 10⁴ or less of bacteria. And then by the time you get to the colon, you see that huge exponential leap in terms of the concentration of microbial life. Every gram of stool has anywhere from 1 to 10 to the 10th to 1 to 10 to the 12th. And that's 10 with 12 zeros after it, of bacteria per gram of stool. And so lots of bacteria along the way. And these are just good numbers to keep in mind, again, for later in the talk, because the jejunum is small intestine, and it's not supposed to have that many bacteria there. And there is a condition called SIBO, small intestinal bacterial overgrowth, which we'll talk about shortly, in which there is more than that number living there. And that is a problem for some people. So real quick, what do our gut microbes do? Why are they there? They have a whole bunch of roles, starting sort of from very early in life to kind of train and help maintain the immune system. And so this, I don't know if you're familiar with the old friends hypothesis. It's kind of like the next iteration of the hygiene hypothesis, which is we co-evolved with a whole bunch of microbial critters throughout, human existence. And our exposure to microbes very, very early in life kind of taught our immune system what to react to, what to tolerate, what not to overreact to. And this idea that the fewer microbial exposures we have early in life may be one of the reasons why there's so much autoimmune disease coming now, that our immune system isn't being trained to tolerate dirt and all sorts of germy things. And so it is kind of going haywire later in life. And that's the old friends hypothesis, that as we got cleaner and we had less fewer microbes kind of living within us in a commensal way, the immune system may have a tendency to go a little bit crazy. The bugs throughout our lives help maintain the mucus barrier in the gut, which is super important for immunity. The microbes kind of induce goblet cells to produce mucus. And when we starve the gut microbes and don't give them enough fiber, they actually degrade the mucus barrier to feed themselves. And so the importance of feeding your microbiota to maintain the mucus barrier is twofold. They also help induce our gut cells to produce various types of immune cells. And so really important for our immunity. They also do things for us. We host them and they give back. They produce a variety of different vitamins, various amino acids, and short chain fatty acids, which have a variety of health effects, including possibly a role in colon cancer prevention. They also help modify bile acids so that they can be recycled to create new bile, a digestive fluid. And that's a role for the microbiota. The microbes also help us access calories from fiber. And so up to 5 to 10% of our daily calories may be liberated by the gut microbiota. And they do also have a role in maintaining cholesterol and lipid balance. And there are specific species and strains of bacteria that specifically have been identified to this end. More and more research is also kind of characterizing the microbiota almost like another organ that can communicate with the brain and other organs, whether it's through the vagal nerve or through various metabolic byproducts of their fermentation process. And so the metabolic byproducts of the microbes are called the metabolome, and that's like the metabolites that they make when they digest food. And there's some really interesting kind of frontiers in microbiome research as to whether we should just like skip this whole idea of supplementing probiotics and go straight to supplementing some of the byproducts that the microbes actually make for us. And maybe that's really what's the important thing. And so a lot of really cool research going on to figure out what they make and how those things affect us physiologically. Super interesting stuff. I think a really important point to ground us, especially before a conversation about the stool test piece of this, is that your gut microbiota is really complex and its health is really contextual. So what we have here are pictures of two ecosystems, right? Like a northeast deciduous forest and a tropical rainforest. Which one of these ecosystems is healthier? Well, if you are a tropical monkey dropped into this northeast forest, that is not a very healthy ecosystem for you. That would be a terrible ecosystem for you. And if you're a reindeer dropped into a tropical rainforest, that is a terrible ecosystem for you, right? Neither one of these is healthier than the other. They're different and they are adapted to and adapted for the creatures that live in them. And we can say the same things about our individual gut microbiota. There's no single archetype of what a healthy gut microbiota is. What's healthy for someone living in urban China might be really different for someone living in rural Nebraska. You can have two very healthy but very different microbiota. And that's super important because when we start talking about these clinical stool microbiome tests and sort of some of the data that they produce around telling people that you have too much of this, not enough of this, you know, you have too many that are, you know, of this critter that is not healthy, or compared to a healthy person, you don't have enough of this critter. You know, we have to bear in mind that it's not really clear that there is one standard of what's a healthy microbiota for anyone. And so file that one away. We'll come back to it later. What we do know about a healthy microbiota, however, is that diversity in terms of the number of different types of species and strains, as well as abundance, right? The sheer number of microbes that we have in our microbiota are both positively associated with good health outcomes, okay? So diversity and abundance seems to matter, even if the cast of characters isn't necessarily set in stone as to who you want to be harboring in there. Okay, so what factors are associated with diversity and abundance? So there's a bunch of stuff that we can no longer control as adults, the things, exposures that happened to us in childhood and decisions that our parents made for us, between, you know, the method of our delivery to the method of our feeding when we were infants, whether or not we had siblings or pets and were exposed to all the germs associated with that, whether we got to play in the mud or whether our parents, you know, rubbed us down with, sterile antibacterial lotion in our, perfectly sterile kitchen. But there are things that we do in adulthood that can still influence the diversity and abundance of the gut microbiota. Exercise improves it or increases it. Adequate sleep is associated positively. And a lot of diverse plant-based foods. And so I wrote here 30 per week, and that's the shorthand. Recent data from the American Gut Project, which is this huge crowdsourced research project out of the University of California, San Diego. They have like 17,000 stool samples of people that were submitted along with food diaries for a week that enabled the researchers to kind of just do a lot of descriptive statistics around what people's critters look like on the inside, compared to what they're eating. And what these researchers found is that the people who have the most diverse and abundant gut microbiota are those who eat 30 or more different plant species per week. And so like, forget 5 a day, fruits and vegetables from when I was growing up, like 30 per week is the new number. And I think that for us as clinicians, that's just a really important thing for us to remember. We've got patients now who are adopting all sorts of diets, from Whole30 to paleo to all keto to, all sorts of different diets that might cut out entire food groups of grains and legumes and nightshade vegetables and, all sorts of things that people are cutting out of their diets. It's a lot harder to get to 30 per week when you've cut out 2 to 3 food groups of plant-based foods. And so that's just always something to keep in mind. If we're looking for gut health, sometimes what you're not eating could be hurting you. So just bear that in mind when you're thinking about your patients on very restrictive diets. In terms of what factors are negatively associated with microbiota diversity and abundance, again, we go back to some of our childhood exposures. Taking antibiotics in infancy and early childhood, especially in that first year of life, and especially multiple courses of broad spectrum antibiotics. Our diet, there seems to be this sort of window of opportunity from age 0 to 3, where we're kind of shaping the parameters of, and the cast of characters is being populated in our guts. And then after age 3, it becomes remarkably stable, which, that would have been good information to know at the time. And so this idea that, once you're kind of, a school age child, like we can make small modifications around the margins in terms of our diet and upregulating and downregulating, who's already in there. But it's actually not so easy to introduce new casts of characters into the ecosystem after age 3. Lots of kind of hyper hygienic, germophobic practices in early childhood is also negatively associated with diversity and abundance. And then the things we do in adulthood can really make a difference. And so very, very low carb diets are associated with reduced diversity and abundance, especially the keto diet. Unfortunately, even the low FODMAP diet is associated with reduced diversity and abundance, which is why, a program, whether it's the Epicured program or sort of the maintenance phase of the low FODMAP diet, is always really encouraging people to eat those tiny bits of the allowed portions of higher FODMAP foods, like for example, 2 Brussels sprouts, right, is low FODMAP. And so eating those 2 Brussels sprouts is important rather than just like cutting out. So really kind of pushing the limits of a low FODMAP diet for your patients who are on it and not being super, super stuck to the most restrictive elimination phase of the low FODMAP diet can be really important for good gut health for people who need to follow the diet longer term for symptom management. Smoking and alcohol are negatively associated with diversity and abundance. Lots of bleach and antimicrobial ingredients in house cleaning products and in personal care products. Certain medications that a lot of people take for years and years. Proton pump inhibitors, statins, metformin, opioids, certain antipsychotics. And so certain medications can affect the microbiota and not for the better. And then certain artificial sweeteners. I think you might have heard that Splenda and potentially aspartame. And so there's things that are within our control and things that are not within our control. So shifting now into sort of how do we get a glimpse? What are some of the diagnostic tests available for a clinician to really understand what is going on inside somebody's body? There's a bunch of different types of tests. We're going to kind of race through the first couple so that we can really get to the stool testing and breath testing in plenty of time. And so starting with endoscopy, there's a whole bunch of different imaging that we're going to talk about so that doctors can visualize the different structures and see if they look normal, if there's abnormal things going on, to see, if there's a lot of poop in there that shouldn't be there, and variety of different ways to image. We'll talk about those momentarily. We'll talk about stool testing, and we'll talk about breath testing. Those are a lot of the tools that a GI doctor will have at her disposal when she is trying to diagnose a patient. So let's start with endoscopy. So endoscopy is basically sticking a very flexible video camera in either through a patient's mouth or through their rectum to visualize part of the GI tract, okay? If you go in through the mouth, it's called an upper endoscopy or an EGD, and it can get as far as just that first part of the small intestine, the duodenum. So you can see the esophagus, the stomach, and that first part of the small intestine, and that is enough of the small intestine, for example, to diagnose celiac disease. And so upper endoscopy is what a doctor would use, for example, to diagnose celiac disease, as well as some other things as well. Colonoscopy kind of goes through the other end, and you're seeing the colon and just the very end part of the ileum of the small intestine, the terminal ileum, which leaves kind of this whole huge, like 18-foot neighborhood of the jejunum and most of the ileum that we cannot reach by conventional endoscopic interventions, which, thank goodness, has come along something called capsule endoscopy, which allows you to kind of access that part that historically has been, out of reach for us. Capsule endoscopy is basically a video camera pill. It's a pill, it's enormous, but patients somehow manage to get it down. And it's amazing. It can capture images of the entire length of the GI tract, including, the whole small intestine. It can calculate the transit time. So it knows exactly how long it takes for the pill, how long it's been in the stomach, each part of the small intestine, the colon. It can measure the pressure of the ileocecal valve to see if that's functioning. It can do a whole lot of stuff and deliver a whole lot of data. And so a lot of different ways that doctors can visualize the inside of a person's body and diagnose various things: celiac disease, Crohn's disease, fistulas, rapid transit, slow transit, all sorts of really terrific things. And so this is sort of the first way to get a peek at what's going on inside. Traditional endoscopy does require sedation. Capsule endoscopy does not. You're awake, you swallow a pill, no biggie. Imaging. So there's a lot of different ways we can also get images of what's going inside. And so x-rays, I think we all know what an x-ray is, and a traditional x-ray is kind of cheap and cheerful. You can get it, it's very widely available. It's not particularly invasive. Radiation is not particularly high. And the problem, however, with traditional x-ray is that while it shows you a bunch of internal structures, in an x-ray, the images, everything is overlapping. You see the bones and then the organs and all the blood vessels, and kind of it's all layered and overlapping on top of each other. And sometimes those layers can obscure your visibility into something that you might be looking for. So traditional imaging from an x-ray might get you a helpful image, or you might not be able to see what you're looking for. In our GI practice, the most common x-ray I see is called a KUB, which we basically take a quick x-ray to see if somebody's full of poop. And that's, that always shows up on the x-ray. That's really easy. To get around some of that layering problem, you might have heard of CT scans. And a CT scan is x-ray imaging. But what it does is it allows you to see cross sections. And so kind of to take each layer and separate it so you can look at every single layer separately. And so you're not getting those overlapping things. You get a much better picture of the soft tissues and the blood vessels, a lot more detail. A version of a CT scan called a CTE can even show like really great detail around how thick the bowel walls are, which is really important for diagnosing Crohn's disease. And so those are some of the x-rays. And then there's barium fluoroscopy, which is a version of x-ray where you actually can see things in real time moving through the GI tract. And so someone might swallow some barium, and then we watch it move through the upper GI tract, and we can see, is there any blockages? Are there any strictures or narrowings? Are there any ulcers? And so you can kind of see if there are any abnormalities by watching this liquid move through. There's also something called a small bowel series, which is kind of the barium moving through the small intestine. And so all of those are different x-ray ways to look inside the gut. There's sound wave-based imaging like ultrasounds, which, again, are pretty cheap and cheerful. They're easy to access. There's no radiation involved, so they're safe for people. Even in pregnancy, you can see some gallstones, you can see tumors, and so ultrasound is another way that doctors can look inside. And then there's magnetic type of imaging like, MRIs, which I think we've all heard of. If you don't work in a GI practice, you may not have heard of an MRD. That's an MR defecography. And that's, it's awkward for the patient, but it yields amazing data. It's basically allowing you to watch somebody's pooping muscles in action, where they're trying to kind of, poop out a contrast substance that was delivered by enema, which is a really helpful way to diagnose people who have pelvic floor muscle dysfunction that is causing their constipation. And so doctors have a ton of different imaging options at their disposal that are, really great at delivering different types of data depending on what the doctor is looking for. There are also studies called nuclear studies, and nuclear studies involve radioactive contrast material, okay? And what we use nuclear studies a lot for is for motility testing, to see how things are functioning, not just static views, but to really see how things are moving. And so the most common one you've probably heard of is a gastric emptying scan or gastric scintigraphy. And that basically is for diagnosing gastroparesis. Is somebody's stomach too slow to empty, or is their stomach emptying time normal? That would be a nuclear study. There's a version of this test that doesn't just measure the stomach emptying, but in fact, the entire GI tract, your small bowel and motility, as well as your colonic motility. And that's really, really helpful, especially again, when we get to the end of this talk, or patients who are getting breath tested and told they have SIBO, or small intestinal bacterial overgrowth. One of the reasons someone can get SIBO is if their small intestine is slow. And if someone is working in a practice that doesn't have a gastroenterologist, they might be under the care of a naturopath or like a functional internist or an integrative doctor or a chiropractor, and they are diagnosed with SIBO, they might just be put on, a prokinetic medication, a motility drug, because they're told, oh, well, your small intestine must be slow, take this medication basically forever. Well, we can actually measure small intestinal motility. And if you don't have slow motility, you should not be on a prokinetic drug forever. And so I think it's important for us as clinicians to know that that's something that happens fairly commonly nowadays, and that you might be able to play a role in referring a patient for motility testing that is, that will give you objective data. Is somebody slow? Are they not slow? And that would be done through a nuclear study typically, or a capsule endoscopy. There are also HIDA scans, which somebody with gallbladder disease might get, or suspected gallbladder disease, to see if there's any blockages causing, pain after eating, and less relevant to this conversation, but helpful to know that that exists. Okay, so stool testing. So stool assays are different than stool microbiome testing, which we're going to talk about shortly. Stool microbiome testing is checking the DNA of the bacteria in the stool, and we'll talk about that shortly. But there's a number of other stool tests that a doctor can do to diagnose a whole wide range of different things. For example, do you make enough pancreatic enzymes? That is a stool test to check elastase levels. Someone who has inflammatory bowel disease, is it in remission, or is it, is the inflammation starting up again? A simple stool test of calprotectin, which is a protein, can give a doctor an inkling as to whether there is inflammation in the bowel or not. If there's blood in the stool, a doctor wants to know, do you have a GI bleed? Do you have a hemorrhoid? Could there be cancer? So detection of blood in stool is a test. If someone's having raging diarrhea, a doctor will use a stool test to see if they're overgrowing a pathogen like Salmonella or E. coli. And based on those results, might offer other specific toxin tests, like for C. diff. Do you have a parasite? If you have a lot of sort of like refluxy, ulcery kind of pain, a stool test can help diagnose H. pylori infection, which is the bacteria in your stomach that causes ulcers. There are newer tests for colon cancer, a DNA test that can be done through stool testing for patients who are lower risk and might not want to do a whole colonoscopy for their colon cancer screening. There is a new FDA-approved test for colon cancer that is a stool test. And doctors can also just check your electrolytes in the stool to help, again, for a case of diarrhea, understand what might be causing the diarrhea. So there's a whole bunch of things that a doctor can order a stool test to learn about you. It's kind of like reading the tea leaves, right? Like reading your stool, you can learn so much information. And these are, some of the big ones that you'll see in a GI practice. Okay, so now we're going to shift into really the focus of why you're all here, which is to talk about two of the newer tests that are out there. Excuse me, sorry. And we'll start with breath testing. So what breath testing is, it is a measurement of exhaled gases or gases on your breath. And these gases are produced by bacteria that are metabolizing some sort of substance that we made a patient drink, a sugar of some sort. Currently, the gases that we can measure with breath testing are hydrogen and methane. And typically, these tests are used to diagnose either like a carbohydrate malabsorption issue, like a lactose intolerance or fructose intolerance. There's a different type of test used for sucrose intolerance. It's not quite the same, but it's a relative of this. And we can use breath testing to diagnose SIBO, small intestinal bacterial overgrowth. And to do that, you can either test with glucose or lactulose, which are different sugars, and we'll talk about that shortly. And the way it works is that a patient comes in, they haven't eaten anything, they breathe into a bag, we measure the gases on their breath just sort of as a baseline. They drink some water with a standardized sugar solution of either lactose or fructose or glucose or lactulose. And then every 15 to 20 minutes for ideally 3 hours, the patient will breathe into a bag, we feed that breath sample into a machine, the machine spits out how much hydrogen is on the breath, how much methane is on the breath, and magically we can diagnose things. And we'll talk about how we do that. So there's increasingly now direct to consumer availability of these tests. And if not direct to consumer, then to consumers through people other than medical doctors. And so these tests are really much more widely available. So I think it's super important for us clinicians to understand the type of data that our patients are getting from practitioners from these tests, and what these data mean, and importantly, what they don't mean, so that we can help our patients navigate what can be an overwhelming amount of information. So hydrogen breath testing basically works by understanding that if there's hydrogen or methane on somebody's breath, it is there because a bacteria made it, okay? Human cells do not produce these gases. So how do these gases get on our breath? If bacteria in our gut encounter unabsorbed fermentable sugars, they will produce these gases, okay? That's pretty much how these gases end up on the breath. They kind of leach out of the bowel into the bloodstream, and then we breathe them out. The trick is the timing of when these gases appear on somebody's breath relative to when they were given a fermentable sugar to drink can be used as a proxy as to where the bacterial fermentation was taking place in the GI tract. Okay, so how is that possible? It's possible if you assume that a person being tested has a normal transit time. Okay, and that is a big assumption, right? Not everyone has normal transit time. If you have gastroparesis or a slow to empty stomach, these breath tests are not going to be very reliable for you. But in someone with normal transit time and they are fasted, they haven't eaten anything, in 12 hours or so, and we give them a liquid to drink, that liquid should clear the stomach within 60 to 90 minutes. And then it moves on to the small intestine. And again, that liquid should clear the small intestine within 60 to 90 minutes. So if you add up those transit times, those range of times, then you get to that liquid should arrive to the beginning part of the colon within 120 to 180 minutes. That is normal orocecal transit time, or oro-mouth cecum, which is the first part of your colon, orocecal transit time. That is a normal transit time for people who don't have abnormal motility. And so if we give somebody something to drink and we start seeing gases sort of, before 120 minutes, we should assume that those gases originated in the proximal GI tract, like the small intestine, for example. And if we see gases show up in somebody's breath, at say 140 minutes or, sometime between 120 and 180, we should assume that those gases were generated in the colon. That's how breath testing basically works. Now, the caveat here is that you don't want to use 120 as a cutoff because that's cutting it really close. What if you're fasted and, drinking a bunch of concentrated sugar kind of, makes things run through you a little bit more quickly through osmosis. And so sometimes the test itself can provoke a little bit of a speediness in terms of transit time. So we use a different diagnostic cutoff. For the purpose of breath tests, we assume only before 90 minutes. If we see something on the breath before 90 minutes, it is safe to assume that fermentation happened in the small intestine. Even though really 120 is a normal transit time, we give ourselves that cushion so that we don't make false positives. Okay, I hope that makes sense to people. And so anytime you're looking at a breath test and you see kind of numbers going up and down, you're looking at when they go up. If those numbers at a test go up in the first 90 minutes, you should assume that those gases were generated in the small intestine. And if they go up after 120 minutes, you should assume that they were generated in the colon. Between 90 and 120 is a little bit of a no man's land, right? But we would not assume that that's happening in the small intestine. Okay, so are breath tests reliable? I think one thing that I hear a lot from patients coming from other practices, when the patient has looked online and they think they have SIBO and they ask their doctor, can I have a breath test? And the doctor says, I don't believe in breath tests. I don't believe in that. Well, I mean, I understand it because breath tests are notoriously noisy, okay? The data can be really, really noisy. And so the reliability of the data is going to depend on, you know, how well the test was executed, how well the patient was prepped. And there's a lot of room for error along a lot of dimensions. These tests are not perfect. The data they provide can be helpful in facilitating a diagnosis, but they are not ironclad. And so, for example, the equipment used can generate noise. If a machine is not calibrated, it can give you wildly inaccurate numbers. I once was given a breath test data from a patient who ordered it from the internet, this company, I won't mention any names, and their baseline reading, the number of, like the amount of hydrogen they had in their breath at baseline was a negative number. Like, how do you have negative hydrogen on your breath? Obviously you don't, the machine wasn't calibrated. So how do you trust any of the readings from that test? It was a useless waste of money. Some older tests will only measure hydrogen gas. That's a problem because about 5 to 15% of people harbor a type of microbe called archaea, which are not quite bacteria. And archaea take hydrogen and they turn it into methane. And so these people aren't going to have any hydrogen on their breath. They're going to only have methane, or at least have some methane on their breath. And if you're not measuring it, you can't capture it. And so you might have a false negative there. Some patients shouldn't get breath tests. Like I said, you know, if you don't have normal orocecal transit time, if you have gastroparesis, if you've had, you know, gastric bypass surgery, so you have like an altered anatomy and things obviously are moving through you faster, you're not a good candidate for these tests. The numbers are going to be kind of meaningless because we can't rely on normal transit times to use as a proxy for where the bacterial fermentation is happening. Like there's a lot of noise that can be introduced in the prep. If someone's not fasted, if they ate a super high FODMAP meal the night before their test, ate a lot of beans and Brussels sprouts and what have you, you might see a lot of gas on their breath before you even start the test. People who have poor oral hygiene, dentures, if they smoked that morning, if they worked out that morning, all of these things could give you a false positive. If someone has a really high stool burden, if they're really, really backed up and constipated, sometimes they'll have a lot of methane in particular on their breath. And that can look like bacterial overgrowth, but really it's just poop. And so that could be a false positive, especially if you are not very experienced in reading breath test results and you don't know how to recognize that pattern, you might call that positive. If someone just took antibiotics recently or they had a colonoscopy a week or two ago, you'll get a false negative. All sorts of medications that mess with your transit time can affect breath test results. If you took Imodium a day or two before, if you take Miralax every night because you're constipated, medications that affect your bowel motility won't give you an accurate read on a breath test. And then the different sugars that we use, especially for bacterial overgrowth, will give us different results. Generally speaking, you'll have a higher risk of a false positive with lactulose. But what lactulose does is if you test negative with lactulose, it's pretty certain that someone doesn't have overgrowth because lactulose is more likely to overpredict overgrowth than underpredict it. And glucose has a higher false negative rate. Glucose is more likely to miss overgrowth. But if you've got a positive glucose test, you definitely have overgrowth. It's really hard for you to get a false positive from glucose. And so, the sugar that you use to test can influence the results. And so it's understandable why some doctors feel like, oh, wow, these tests aren't so terrific. I don't share that skepticism. I think that, the tests are really helpful data. Very often they yield terrific data and terrific diagnoses. Sometimes they're equivocal. And it's like, oh, I don't really know what to do with this data. It's not super duper clear, but it was worth a try. And sometimes, every so often you'll get a false negative and you'll think that you've ruled something out that is there. And so they're not perfect, but if you can control for this noise, they can be really helpful. And we quite like them in our practice. Um, the last thing also is, for doctors who really aren't very experienced interpreting breath test results, the data might be perfectly great data. The numbers are good numbers. It's just the person reading the test doesn't know what to make of those numbers. And so I think it's really helpful to work with a practice that does a lot of breath testing, that's been doing it for years, that really stays up to date with it and understands how to interpret the data, so that when the data are good and are not noisy, we're actually drawing appropriate conclusions from them. And so kind of in reviewing this idea of, our breath test reliable, I mean, I think that these authors from 2014 really summed it up well, which is, you can maximize the diagnostic accuracy of breath tests by making sure that you choose appropriate patients for the testing, prep them really well, standardize the test, and interpret them, in evidence-based ways. You'll get the most out of these types of tests. And so are they reliable? They are reliable enough, and they're the best that we have right now. So I want to shift now into some of the stool microbiome analysis tests. These are kind of new to me. I've probably only been getting them brought to me for the past maybe 2 years. I've never ordered one, but patients will often come to me with these like 50-page printouts that another practitioner has ordered for them. And what these things are is, they are basically these very extensive readouts that give a lot of information about the bacteria in your stool. And it's based on kind of sequencing some of the DNA. They cost a few $100. They are not FDA approved to diagnose any condition. A lot of different companies are playing in this space, and they will offer somewhat different products. But basically what you can expect is a partial list of the different types of critters that are living in your colon. Certainly not an exhaustive list, and certainly not even drilled down to species or subspecies or strain level. It's that very high level data, usually at the level of genus or genus species, but not usually down to the strain. And then what they all do is they kind of give some commentary around whether your levels of different microbes are appropriate, too high, or too low. They don't tell you what the reference data is. Who is this person, or what is the range that they're comparing you to? And so I want to kind of just draw you back to what I mentioned earlier in this talk, which is currently we don't have an evidence-based, standard of what a healthy microbiota is, nor will we ever, probably, because there's such variation. And so there are no current evidence-based standards for what appropriate or normal levels of various microbial taxa are. But still, these tests are kind of comparing you to an unknown reference and giving some commentary on how you are great or how you fall short. They'll give some commentary about certain microbes that are within you that have been associated with disease risk. And as I'm sure we all know on this call, correlation does not equal causation. And very often, I think universally, these tests will make recommendations about a supplement, a probiotic, a diet, based on the test results. And then some of them will also give just some like sort of descriptive data about other stuff in your poop, ranging from what its pH is to, what short chain fatty acids are in there, just various things like that. And that will, again, vary by lab. This is just kind of like some screenshots that I pulled off the internet from various companies to give a sense for what some of the printouts or the readouts from different companies, what a patient might be given when they get the results. And if we're looking at the one on the far left with all those blue bars, what you'll see is sort of like that top section that says like normal commensal bacteria. Those are a whole bunch of different genus, bacterial genera, which is plural for genus, right? And so this is very, very high level data. Bifidobacterium is a genus. It is not a species, and it's not even a strain. And so which species of bifidobacteria are in there? Which species of lactobacillus? Which of the Escherichia species are in there, right? And that's really important. Like Escherichia is, I think we all know it as E. coli, but the first probiotic ever discovered was an Escherichia, right? So Escherichia as a genus has some probiotic bacteria. It's got some killer pathogens in there, like, things that you'll get from like undercooked ground beef that will kill you. and then it's got a whole bunch of commensals. So if you're told that you have, you know, 2 high levels of Escherichia, like what does that mean? Do you have really high levels of the good ones, the commensals, or the bad ones? Like the level of data you're given in a test like this doesn't really tell you that. You'll also see kind of the highs and the lows, which it's not clear what the established benchmark is and high relative to who or to what. And who's to say that that person is healthier than you are? It's not really clear what the reference ranges are here. And then there's kind of some classification of what opportunistic bacteria or what they call dysbiotic or imbalanced bacteria that they are kind of putting a value judgment on, saying like, oh, you shouldn't have these or you have too many of these, which again, it doesn't necessarily indicate anything about illness because we're getting a very sort of limited picture. We're not seeing what's balancing them out and sort of what the big picture looks like. And so it's really hard to kind of draw any conclusion other than to be really scared by seeing a long list of things that you're told are opportunistic and which are often kind of setting you up for a pitch to buy a probiotic. You'll see on the far right, a lot of companies are giving diet recommendations telling you like, oh, based on your microbes, you should eat garlic, beef, apples, leafy greens, and asparagus. I can't imagine why anyone would tell you to eat beef to augment your microbiome because it has no fiber, but there it is. And then, you know, they're telling you to avoid certain foods. You should avoid cashews. Unclear why. A lot of personalized diet recommendations. In my experience, a lot of the diets that you're given from a test like this will typically give you between 3 and 4 dozen foods that you're supposed to avoid. And that's usually when a patient will come into my practice, which is someone ordered this test for them. They come in, they have 4 dozen foods that they're told they have to avoid. And they're like, what am I supposed to eat? The good news is I could be like, well, just throw that away. None of it means anything. Let's just start from scratch. But it can be really overwhelming for a patient to be giving that amount of data that seems not to have any evidence basis. In terms of whether clinical microbiome tests yield meaningful data, my answer would be very little. So some of them will give you a little bit of information about like your stool elastase levels, which is like, great, you know, you could have just gotten a regular stool test for that. They might tell you that about your short chain fatty acids, which is just a marker of whether someone's eating a lot of fiber, basically. But pretty much a lot of this data is somewhat not actionable and it's certainly not diagnostic of anything. As I mentioned earlier, it's not clear what these benchmarks are that they're comparing you to, and they're not validated. There are no normal ranges for any individual microbial taxa established. As I mentioned also, there's really not any specific detail on species and strains, and that also limits the usefulness of the data. And this idea that we're mentioning, oh, you have this one, and you know, a lot of people with, you know, Crohn's disease have that one, there's a correlation. Well, you don't really know as a patient what percentage of people have that critter and don't have Crohn's disease, right? So it can be really, really scary when you're kind of given these correlations without any context. And you kind of it makes you assume a causation that these are risk factors, and it really may or may not be that way. And so, you know, I think in the research community, the current conclusion is it's interesting. This data is interesting. We all are so curious to know what's inside us, but there's really a long way to go before these types of tests can be used in a diagnostic way in a clinical setting. And so we're not there yet. We don't know what to do with all this data. It doesn't really mean very much right now to us. In terms of the diet recommendations offered by these tests, I interviewed the scientific director of the American Gut Project, who gave me like the saltiest quote ever. So of course I had to put it in here, that there is no data linking what microbes you harbor inside and what the diet implications are. There's no data that suggests if you look like this inside, you should eat that. It's not based on anything, and it's not really clear where these diet recommendations are coming from. And so getting back to this idea of, 30 per week or 30 plants per week is really optimal from a gut health perspective. Do we really want to be telling people to take 4 dozen foods and don't eat them? I'll also say, having seen some of these diet recommendations personally, they're really kind of curious. And so I've seen one test, for example, comes to mind, where a patient was told not to eat black-eyed peas and red kidney beans, excuse me, but they should eat white beans and black beans. like biochemically, these things are really not that different. Like what, critters are growing on black-eyed peas that are so horrific that you need to avoid them that you wouldn't be feeding if you ate white beans, right? So some of it just kind of doesn't stand up to sort of the common sense test. And again, it's not really clear what these recommendations are based on. It's also somewhat problematic because a lot of these tests are being used to recommend probiotic supplements and, like I mentioned, diet change. It's actually really, really hard to change the microbiota. Like if we knew how to do it, we would be doing it. Probiotics, for example, don't really colonize the microbiota in a meaningful way. And once about 50% of people, they don't colonize at all. And people who they do kind of get benefits from it, once you stop taking the probiotic, you don't see the probiotic strain in the stool within a week of stopping to take the pill. These things don't become part of you. If they have a benefit, they're having a benefit on their way through. Other than prebiotic fiber like inulin, which has been linked to increasing a specific genus, bifidobacteria, other dietary factors have not been linked in a one-to-one way with specific critters. And so you can't say, if you eat more spinach, you'll grow this species and strain. And if you eat more apples, you'll grow this species and strain. Like that level of data don't exist. And even like stool transplants don't really seem to dramatically change the microbiota. And even when they do have a beneficial therapeutic effect. So it's really, really hard to change the microbiota. We don't know how to do it yet. And so I think a lot of the recommendations that come out of these tests are very, very premature and not evidence-based. And so I want to, leave time for questions. So I think my parting thoughts are consumers are super interested in gut health. The microbiota is being written about everywhere. There's tests promising to diagnose this and to do that. It's important for us to understand what is being promised, what is being claimed, and to help our patients navigate what's real, what's not real, to help keep them sane through the process because they're being exposed to so much data and not all of it is meaningful, clinically relevant, or actionable. And it's also important for us to know if a patient is worried about inflammation, you can't necessarily diagnose that from a breath test or from a stool microbiome test, but you should know how to diagnose it. Or if a patient's worried that they're slow, it's important for you to know which tests can measure that so that you can refer them to proper, appropriate tests and people who can deliver those so that your patients can get a diagnosis and stop Googling and self-diagnosing and just get answers and get objective data. And so to be really familiar with what is evidence-based, what is available, and what some of these newer tests can do and what they can't do is super important. And so with that, I'm gonna stop and open it up for questions.
Thanks so much, Tamara. Yeah, and that's the reason why we had you on the webinar tonight was to be able to really make those distinctions because it can be hard to figure that out. Okay, without further delay, I do want to have some time for questions. We did get a couple in. Just again, guys, if you have any questions, if you hover over the screen, you see the buttons on the bottom. You just want to chat in your question via the Q&A button. So the first question we got, Tamara, is if someone tests positive for fructose or lactose malabsorption, can we skip these tests in FODMAP reintroduction?
That's a great question. And so the first is what I'll say is you want to make sure that the positive test was indeed lactose and not fructose, not overgrowth. And so, for example, one thing I've seen a lot is somebody who actually has bacterial overgrowth or SIBO, they're given a lactose intolerance test or fructose intolerance test, and the doctor's like, oh, it's positive. Get the data. Because if those numbers went up in the first 90 minutes of the test, right, as I mentioned, that is not lactose intolerance or fructose intolerance. That's in the small intestine, that's SIBO. So you want to make sure, first of all, that your patients that are told that they have lactose or fructose intolerance actually have that and not SIBO. So
get the lab.
Get the labs. But to your question, I mean, what I'll say is that if you do already have data that somebody is not lactose intolerant, like they're not a lactose malabsorber, then or fructose malabsorber, yeah, absolutely. If you're going to try FODMAP elimination with them, you can go ahead and kind of include, lactose and dairy in their regular diet without eliminating that in phase 1, because the tests give you 25 grams of each of them at a time. And if you don't get sick after having 25 pure grams of lactose, which is basically like 2 entire full glasses of milk, like the amount of lactose you would ever eat in a sitting on a physiological basis is never going to be that high. And so I think if they don't get sick after the test, forget what the numbers say. If they don't actually feel sick after the test, then I don't think that you have to eliminate them in the phase 1 elimination of a low FODMAP diet. I wouldn't.
Okay. Okay, great. We have a couple others. Not sure if you've seen this, but I'll ask it. What are your thoughts on the new genetically modified probiotic?
Oh God. I haven't seen it, so
Okay.
I don't have thoughts on that specifically, except to say that in general, probiotics are not a big part of my practice. I don't think that they have a whole lot of clinical utility for the types of cases that I see. And there's so little evidence linking specific probiotic strains to various clinical outcomes that I really reserve my probiotic use for things that have been tried and tested. And so, for example, there's a product called VSL number 3 that has really, really good clinical data that it helps with ulcerative colitis. So if someone has ulcerative colitis, they'll get that specific thing. But, you know, a new product that is out there, I doubt it's really been tested in any kind of clinical setting and doesn't have the really robust data of the stuff that's been established and really looked at. And so I tend to shy away from using a lot of probiotics in my practice.
Okay, perfect. What about food intolerance tests? How do you feel that they are supported by the research, like the IgG and IgE tests?
So IgE is not a food intolerance test. IgE is food allergy test, and that is one step in the process to diagnose a food allergy, right? And so to have a food allergy, you have to have first sensitization, allergic sensitization to the protein, or an elevated IgE. But an elevated IgE alone is often used very inappropriately, that if the number is high, then a doctor will be like, oh, you're allergic. Actually, the majority of people who are sensitized, who have an elevated IgE, are not actually clinically allergic to that food. And so using an IgE test alone to diagnose food allergy is not evidence-based. It is not endorsed by all the allergy, immunology bodies. But it's having an elevated IgE plus a clinically observed reaction to that food is for food allergy. So that's legit. IgG tests are not evidence-based to diagnose anything. They're complete nonsense, waste of money, waste of your patient's sanity. IgG is a memory antibody. IgG measures food tolerance. It will be higher to a food that you eat more often, typically. And to prove that point, or to kind of demonstrate that point, when they're doing immunotherapy now for like the peanut allergic kids and the egg allergic kids, where they give them those tiny, tiny, tiny bits of peanut to kind of build up their tolerance and kind of to cure the allergy, which is kind of the frontier of allergy treatment now. The way that they know that the immunotherapy is working is that they see your IgG levels to peanut going up. When your IgG goes up, that means you are tolerating the peanut better. And so these tests are being completely abused. They're nonsense. I don't use them. I would never order them. I put no stock in any of them.
Okay. Yeah, perfect.
No, was that clear enough?
Very clear. I did just have a follow-up to the VSL number 3 that you mentioned as a probiotic that you're recommending. It looks like someone did a quick Google search and said that VSL number 3 is not currently available. Are you recommending VisBiome instead?
Oh, like the one that's like the VSL knockoff?
I think so.
Yeah, I think that there's one that's like identical, like that's somebody who used to work there. I didn't know it wasn't available. My guess is that if it's literally the same exact combination, then it would probably be fine.
Same.
For, you know, like I said, for ulcerative colitis, for pouchitis, that's what I use VSL for. I don't use it for IBS, and I don't use it for anything else.
Okay. I think we'll do, are you okay to do 2 more?
Yeah, sure.
Okay. Next question is, how significant are calories from short chain fatty acids? You mentioned 5 to 10% of daily calories. Fiber is thought of as a non-nutritive on the nutrition label, but does it indirectly contribute calories to our diet?
Yeah, so calories are not actually from the short chain fatty acids. Calories are just from like kind of breaking down the fiber. Like we can't break down fiber, but the microbes can. And once those bonds are broken, it liberates carbohydrate, right? And so Fiber is not necessarily calorie free, but it's extremely, extremely, extremely low. And different fibers will be different, right? And so a fiber that is more fermentable or more breakdownable by bacteria is more likely to have a trace amount of calories than something that is not fermentable or not FODMAPy, right? Like if, you know, spinach, for example, is really poorly fermentable, not a whole lot of bacteria can break down spinach. You're not likely to even get trace amounts of calories from that versus, you know, maybe like beans, which are like super duper fermentable. And once the bacteria have at that, you might actually liberate a little bit. I mean, is it
like,
yeah, 5 to 10% of your daily calories coming? That's not nothing. But calorie counting is such an imperfect science anyway, right? Like all of it is guessing, right? Like we count calories in these calorie in these calorie trackers, but it's all ballpark. You know, the calories listed on a food can be like up to 20% off and still be legal. Like, I mean, it's all ballparking. I mean, who really knows how many calories like we're all having on a day-to-day basis, unless you're actually doing like the calorimetry, like the breath, you know, the breath measurements, which who does? So, you know, it's something, it's not nothing, but generally speaking, high fiber foods are the least energy dense foods out there. And so I can't imagine somebody getting fat because they ate too much fiber.
Last question. Do you have a way to raise secretory IgA?
I'm not aware of ways to raise immune cells through diet. I'm not aware of it. It's not, you know, I'm not an immunologist. I don't work in an immunology practice, but I am not aware of any such things that diet can do.
From a diet perspective.
Yeah, no.
Okay. Well, thank you so much, Tamara. Thanks so much for attending, everyone, today. I did just want to mention, if you guys are going to be at Fancy in October, we will be having an event at Fancy on that Saturday night from 6:30 to 9:30. You all are invited. We would love to have you. We'll be having Kate Scarlatta speaking at the event. You are all invited to attend. It's going to be very close by and across the street from the conference center. Other than that, please stay tuned for many opportunities to join us in our clinical webinar series. Again, we are so grateful to play a role in supporting this digestive clinical community. Thank you so much for all attending tonight, and thank you so much, Tamara, for the information here.